Hello everyone, my name is Alex Angel and you are welcome to the third part of the tutorial for my recent project Nuke, and this is chapter number 1, and here we will do a camera animation. We will start from the basic animation which we did in our previous parts. So the main idea is to connect the dummy to our already animated camera. So we will keep the basic animation keys, and then to the new created dummy we can apply some noise modifiers for the rotation or maybe position, and the animation will look more natural. So as you see, I created dummy and just connected to the our basic camera, and this big dummy will be like a middleman. Now we need to create another one, smaller dummy, and connect to the middleman. And to the small dummy we can apply controller which called position list. This is very important, and by standing on available we can create assign a controller noise position. This is very important. You must to stay on available. And now you can play with the parameters. This is up to you. You can apply anything you want. I prefer to keep my noise very subtle, so it will not like disturb too much the audience. Now we need a second camera which will be connected to the small dummy with the noise controllers, so we can hide our original camera, create the new one, and the new camera connect to the small dummy which has a noise position controller. So this second camera is already has influence of our noise position. Well, it's not very obvious now when I compare side by side, because we need to apply also rotation. We need to apply same to the rotation. For that we need to select the rotation, create assign controller, also rotation list. This is also very important, and select available, and then create noise controller. And here we also can apply parameters for the rotation noise. And now you can see in the left window that the difference is more than just obvious to the right camera. From the right is our basic animated camera. And now the left one, you can see all these shakes and tremble, which we will see after the shockwave will reach the camera. After all of this, we have two cameras. Let's give them the names. The camera with the effect of shake, and another camera is original one with the clean and smooth animation. So our next task is to create a third camera, and this camera will be final, the camera which will be connected to the clean camera with original animation. And then after the shockwave will reach our position, we will switch the link from the clean camera to the camera with shake. So this third camera will have a name cam render. Okay, and now we need to position this final cam render to the exact same position as our camera with the original animation, the clean camera. So let's freeze our ground so we will not be confused by selecting. select the camera, choose align, and select camera animation with clean animation, the one we had at the beginning of this lesson. And do not move your time slider, stay in the same frame. And for the transformation, we need to apply link constraint controller. And here we need to press add link and choose our camera animation. So our third camera now is linked to the clean camera. We need to input start time, our first frame. And as you see, the camera render at the top left corner is same as the camera cam anim with original animation. Now they are identical. And now we need to find the frame when our shockwave is reaching our position. I think this is I think 1207. And now we press add link and choose our camera shake. And now we have two items in this list, which means at the frame 1200, our third camera will switch from this smooth animation to the shaked one. See, now we have a connection to the shake camera. This system looks a little bit too complicated. Of course, it could be done maybe even with one camera only. But with this system, we are still able to keep working with our original animation or with the camera with a shake controller, so we can increase or decrease our shake influence. So I prefer to be able to work separately with all animation elements, aspects, so I can control more things. And this is our preview. You see the animation looks very smooth. So now we're still connected to the original camera. And at this point we got second connection to the another camera with the shake controller. Okay, it looks nice. After this, our next task will be maybe to adjust a little bit the original animation of the first camera. And I think we can tweak a little bit more the noise controllers. So we will add more tremble to the camera. Let's watch the preview. Okay, nice, clean, and bang. It is already feeling already have this feel that something hit the camera. Bang, yes. It is already very nice, actually. Yeah, need to adjust a little bit the original camera. Yes, at this point we switch the connection to the camera with shake. Okay. Yes, at this point we will add additional animation to the target of our original camera. So let's select the target and let's find the moment right yes, like here, exactly at the moment of contact with the shockwave. Make a key and go a little bit forward. Turn on auto key and then move the position of the original camera target a little bit to the side. So it will looks like we are losing the focus of the explosion, so it's not in the middle of the frame anymore after the hit of the shockwave. So let's check the graph of our animation. I don't know if we need to tweak anything here. Maybe not. Okay, yes, we got this effect, like we are losing the focus of the mushroom for a moment, just like a very powerful shockwave. Okay, let's tweak a little bit more the noise controller parameters, make a little bit more harsh the noise, and let's make a preview and see the result. Yeah, I can say that even here in viewport already can see that the noise looks much better. Okay, let's see the preview. Okay, smooth and nice, and then explosion and bang. Yes. Okay, probably we need to move the camera target a little bit upwards, so we will follow the mushroom in the air, or maybe a little bit decrease the noise. Probably it was like too crazy. So let's select the original camera target again, and let's adjust a little bit animation. I cannot say what exactly I'm trying to reach, but to make some additional keys and make some maybe more small variations in the camera target flow to make it maybe more natural, and yes, a little bit higher. Okay. Let's save the scene and make one more preview. So this is our preview. Nice and smooth and calm, then explosion and bang. Yes. This is it. This is what we need. I think now it's perfect. Yes, very good. So this we can keep. Okay, our next chapter will be the light dust element of our explosion. So let's move to the next chapter. Chapter number 2, and here we will do the light dust effect. Probably the most difficult in this project. Now you're watching the test render of the current version of our scene, and as you see, this is this wave over the ground is the result of our displays, because we added additional layer to the displacement map in the previous part of the tutorial. The map which follows the shockwave sphere, and it creates a kind of like a distortion of the ground. So now we will make the simulation for that area. So for this we need to first of all to create the emitter which will emit our light dust. So now we need to specify the area which will be used from our ground, because we don't need whole ground. We need to keep our emitter as small as possible and cut all unnecessary parts of the surface, because it's too high poly, too heavy. Okay, I think we can work with this view from the top. So let's copy our desert object and let's name light dust emitter. We don't need displays anymore here. So let's remove that parameter, modificator, sorry. And let's add edit poly. Sorry, it's very laggy because the object is very heavy. Turn on poly mode and let's select everything which is outside of the camera view. And delete, because we don't need that right part of the ground. Now select the left side carefully outside of the camera view. Okay, and press delete. Yeah, that is very slow. This is why I'm trying to keep the emitter objects as small as possible, and this outside of the camera range object also, part of the object. Let's delete this as well. Or maybe like this, yes. Because it is too far away, probably our simulator box will be smaller, and we don't need that too far away from the... Actually, this area is behind the explosion, so we don't have even a chance to see it. So now we have our object. Let's turn off render enable because we don't need it to render. Freeze our original ground, and let's create a layer and give it a name, light dust. Well, probably it's not a light dust, maybe it's a thin dust, or I don't know, shockwave dust. I don't know, I choose this name. So our next task will be to create our simulation box, but this box will be very small, just for R&D process, because we need to keep it as fast as possible. Pretty same as we were doing for the dust wave, but here the simulation box is even smaller, just a line. So let's do our usual adjustments. So storage quality, output files, backup intervals, include our ground to the simulation. Let's create a source and target for our source our ground. And let's create a map, a gradient ramp for the outgoing velocity, and let's add our source to the simulation box. And let's start to work with our map. Turn off the temperature because we don't need it. Copy the map to the smoke channel as well. And let's work with the map. It must be map channel 3. To see our map in the viewport, we need to apply material to our emitter. So let's create just a simple material, apply it to the emitter. Let's give it a name, and let's instance the map inside this material. So we will see the result in the viewport. The map itself is just a gradient ramp, the black from the sides, and one point is white. So let's add additional black point. And now we have like a kind of circle over the black background. And let's make an animation that this circle is expanding. And now we need to follow our shockwave object. So we need to create the animation keys for approximately every 5 or I don't know 4 or 5 frames to follow the shockwave sphere. You don't have to be super precise, just approximately the same position in every 3 or 4 frames. Something like this. So the white color is emission of the dust, and the black color is zero emission. So you can already imagine how our light dust will emit from the emitter. And now we are reaching the camera. Let's switch to the camera. And now we need to make sure that we will cover a whole range of the camera view. We need to add more keys at the beginning of the explosion when our shockwave is small. Okay, and one more time. So basically here you will not see this light dust because it will be covered by the explosion. Okay, yes, animation looks fine. It follows pretty well. Let's give the name to this map. And now let's make sure that we were copying the instance and this map is inside our source. Okay, and now we can animate our outgoing velocity. So it must be something around 0.2 at the few frames after the explosion, 0 at the moment of the explosion, and when we reach the camera it must be again 0. Later we will adjust this parameter. Okay, maybe add some curve to keep more emission over the time. All right, let's add some noise. Physical parameters are buoyancy negative 0.85, dissipation is 0, cooling is 0, time scale is 0.7. This is should be fine for the first test. And maybe animate the time scale and make like a slow down from 0.7 to 0.2. Let's add some steps per frame animation as well. since we played with the time scale. Let's delete the first frame, first key, sorry. As you see, steps per frame is related to the time scale. So the faster the time, the more steps per frame we give. Let's animate randomize as well. 5.2 at the beginning and then decreasing to just 0.2. Let's decrease the dynamic, change our fluidity to buffered, and the quality 16 should be fine for the beginning. Okay, and the grid, let's adjust. Well, it covers pretty enough. Adjust the start frame parameter to the frame of the beginning of our explosion. And we are ready to start our first simulation just after the file save, just in case that 3D Max will crash or something. And let's see how our light dust is emitting. GPU preview, maybe not now. It is not the best choice sometimes. Sometimes it's better to stay with basic preview. Okay, it is fine as for the first simulation. Okay, basically the concept of this light dust element of the explosion is to create very thin and very low to the ground layer of the dust, which will be transparent, barely visible, but it will give the better look of the shockwave. And basically we need to just keep our simulation dust low, just closer to the ground. And now it is a little bit too high, I would say. Okay, let's pause our simulation. Let's move our slides to see better. Okay, GPU preview. Yeah, it is nice. Let's change the opacity to 0.999, maybe 1. Yeah, 1 to see better. The more details of the dust. Okay, let's turn on explosion and see all together. Yeah, it is a little bit too high, I would say. Turn off the explosion. Okay, let's add the sphere. Place it into the middle. Just make sure that this is in the right position, just where our explosion is happening. And as you can guess, this sphere will push, turn off the render enable. This sphere will push our dust outside. Let's add body force. Object, target our sphere. Okay, let's change the strength to negative 7. And what else? Let's change these parameters as well. Spread speed. Well, you can play with these parameters on your own. Let's add our new objects to the simulation, the sphere and the body force. Okay, let's increase the time scale at the beginning to 1 to make it faster in the beginning. Save our scene. And we are ready to make another simulation and see the effect of the body force, how it is pushing our dust outside of the explosion. Because now our dust is just emitting from the ground and going upwards, but actually our explosion is creating the force outside of the impact point of the explosion. So it must be like very obvious pushing away force. So dust should fly away, not just to rise above the ground. And now you can see this effect that the dust is being pushed outside of the sphere. Okay, from the side it looks fine. Obviously you can see the pushing force. Yeah, the smoke is flying away, but still too high above the ground, so probably we need to increase decrease the smoke buoyancy to even lower level, and maybe decrease randomizer. As you see, this is basically just about the play with the parameters until you get the right look of your simulation. This is like a very natural way to tweak your simulation. I think we can keep our outgoing velocity at this level. Well, I will do some final adjustments behind the recordings, and I will show you already the final result. So this is it. I made a simulation and the render, and this is the result. You can see the light dust is rising above the ground. You can see it right after the shockwave. Yes, the render is a little bit low quality, but I was trying just to make it as fast as possible. So now I will show you the final parameters. As you see, I made a bigger box of the simulation, which covers the camera view. So this is the final parameters. The cell size 1.35. You can see the smoke buoyancy is negative 1.85. Randomize, you can see the fluidity is still buffered and the quality. This is the graphs for the animation. They are actually, I think, same, just very minor changings. Time scale is 1. Actually, it's just the same as it was before, decreasing to 0.2. As you see, my simulation box is not reaching the camera. As I was saying in the previous parts of the tutorial, here will be a trick. It will be another simulation in front of the camera, which will be simulated with the higher parameters. And the light dust simulation ends just in front of the little hump of my of my desert. So you were watching the animation graphs of my light dust simulator box, and now let's see what's the curve of the source object. And as you see, it looks just the same as before. I just increased at this key the value to 0.3. Yes. And it starts from 0 at the moment of the explosion, and then again 0 in the end. Okay. Let's check the parameters of our body force object. The strength is negative 25, max distance 1500. The sphere is still sphere, nothing special, no displacement, nothing else. Still not renderable. And now let's talk about the problems. When we emit the smoke from the ground, which is not flat, we get these lines. I don't know how to avoid this problem you see on the render with just a simulation. To me, this problem now is inevitable if you simulate the smoke from the surface which is not flat, as actually our desert, and you will receive these lines. So how to fix this problem? I found the trick. If we put to the smoke opacity texture the vray distance texture map, distance value is 6, far color white, near color black, objects is our desert. So how it works, every single cell of our simulation which is closer to the ground will get the opacity 0, which is black color, and it will of course cut some details from the simulation, but at least you will avoid these lines. Okay, let's watch the rest of the parameters. The fire is nothing, smoke color is on your screen, light cache 0.5, smoke opacity parameters. Very important thing that in the vray tab, in the settings, in the global switches, you must increase the max transparency levels to at least 100 to avoid the bugs on your render. Also, it will be used for the vray environment fog as well. The parameters of the environment fog is on your screen. The distance, the color, height is still 700. And now it's time to talk about the problem which hits my render time the most. Is since we are using vray environmental fog in our scene, every single Phoenix simulation must be in a specific mode which calls volumetric geometry. Only in this mode our environmental fog will be calculated correctly. But the problem is that in this mode our simulations they are increasing our render time approximately 2 times or maybe 3 times longer. So you need to take this into account. So I think now it's time to make a final simulation of the light dust. We will make our simulation box a little bit I think wider, because it was still not enough to cover the camera. You see these little corners, it was not enough, so I need to make it a little bit bigger. So let's change our grid, yes, like this, to cover whole camera view. As you see, my simulation box is not covering the backside behind the explosion. I decided to skip it because my camera is pretty low and it's not actually visible. But maybe in your case, if the camera is higher, you will have to take into account the backside of the explosion. Alright, we are done here, and let's jump to the next chapter and create a near dust simulation. Chapter 3, and here we will create a near dust. For this we need to duplicate our desert. Let's give the name near dust emitter. Let's delete vray displacement mod and add we need to add edit poly to kill unnecessary polygons. Let's turn on polygon mode and let's go to the top view and select well, basically we need a very small part of this ground object, so let's select this most of the part of the desert and hit delete. Okay, it's a little bit heavy for the computer. Okay, let's delete the sides of the emitter object, because we need just a small sector of the view from the camera and we don't need much for this element of the explosion. Let's delete backside as well, everything behind the camera. And left side as well. So now our object will be have a small amount of the polygons, and now let's cut a little bit more and hit delete. Okay, nice. And now we need to keep only the small sector in front of the camera. So we need to change selection mode. Okay, it's working. And select only the sector. Yes, like this, because we don't need more. Okay, so basically this is just this just includes the ground between camera and the hump, which will hide the border between light dust and the near dust, these two simulations. So let's see what we got. Okay, it's a small sector. You see this little hump and the camera. So we need only this. Let's make our object not render enable because we don't want to see him on the render. Let's make a layer and call it near dust to keep our project structure clean. And let's create a simulation box. We need to cover approximately our sector of view from the camera, something like this. Okay, make it a little bit higher, because our ground and the space above the ground must be inside our simulation box. Okay, I don't like this seam of my, edge of my near dust emitter is not pretty. Let's make a more straight cut. Okay, hit delete. Okay, now it's pretty, and let's move on. Next step will be let's create a source for our near dust. Let's place it just in the view of our camera, and let's add our emitter. Okay, and let's include our objects for the simulation, both of them, emitter and the source. Let's set our output parameters, and let's hit velocity because we need it. And also let's set our output cache files. Let's change our basic parameters. Cooling 0, timescale 2, smoke buoyancy negative. What else? Some randomized parameters and steps per frame. Okay. And inside our source, let's turn off temperature because we don't need it. And choose the map for the velocity. And the map will be a gradient ramp as usual. Okay, let's drop it to the material editor. Let's give a name to this map. Make sure it's instance. And copy to the smoke channel as well. To see the map again, we need to drop some basic material to the emitter and copy our map to this material, so we will see it in a viewport. Map channel set to 4 and drop additional UVV map to our emitter object. Okay, channel number 4. Because we need to preserve our map channels from the previous parts of the tutorial. I think, yeah, it's a little bit laggy because we need to drop this UV map above the edit poly. Yes. And make sure that the size of the this modifier is right, and it is not right. Okay, something wrong here. Need to figure out. Okay, what it could be, why it's too laggy with such a small section of the polygons. I don't know, let's try to move the map manually. Okay. Oh my god, it is too slow. It's just impossible to work like this. I think it's because we need to convert this object, the emitter, yes, like this, to edit poly and kill the history that it was before. It was a big object, and now with the killed history, you see it is working fast. And again, drop UV map channel 4, and the size is right, and it is working fast. It's all because of history of the object. Okay, now we are good to go. This is our gradient ramp. As usual, let's make a black outside, and we need to make a wave of the white color over the emitter object. So we need to animate need to animate the points on our gradient, but to animate them we need to see animation of the rest of the ground, and we need to match to keep the feeling of the continuity of our simulations. Okay, let's keep animate our gradient ramp. Yes, something like this. Okay. Let's check the graph of our gradient ramp animation. Sorry, my interface is a little bit laggy. We don't need the previous key. Yes, this one. Let's kill it. Sorry. I need to keep selected my emitter object. Let's make linear the last point and kill the key at the frame number 0. This one also linear. And let's check. Okay, it's matching. Yes, it is nice. Yes, let's check with the shockwave. And it looks like wrong. But we can move our keys. Something like this. One frame forward. Let's adjust it. Okay. Yes, now it is okay. Okay, yes, it's just perfect. Just according to our shockwave sphere. Okay, now we can turn it off. Also, I think we can turn off our ground. Let's focus on our near dust. And let's work with our simulation. Okay, let's change our cell size because it's too big. I think we can run our first simulation with these parameters. We just need to change the start frame. Yes, because we don't need to simulate all those frames. Okay, this is the result of our simulation. Let's check with GPU preview. Okay. Well, at least our map is working. This is how it looks from the camera. Okay, looks like we have lots of things to tweak in our simulation. Okay, let's create a planar force because we need to push our dust towards the camera. This time we will do it with the plane force instead of body force. And let's create a rotation list to our plane force object and make a noise to the rotation, just like we did for the camera in the previous chapters, to make some variations in the direction. Okay. Something like this, just to make a little bit more, to add some more chaos to the directions. And here in effect, we need to input smoke because we want to affect a smoke channel. Also, let's animate strength parameter to make it powerful at the beginning, and then yeah, let's kill the first frame key as well, and then make it weaker at the later frames. So now let's change a little bit our gradient ramp. Let's make it gray, the first point, and turn on auto key and add additional point to the gradient ramp. Make it white one more point and make it dark gray. So our map will be kind of a white wave. Yes, it's a little bit messy, but we need to move these new points behind the first one, which was created. So basically you need to just achieve this kind of effect with a moving white wave over our gradient ramp. I think it shouldn't be a problem. It's a little bit messy. Maybe I could build this gradient ramp from the beginning, from scratch, but I will fix it here with the curves. So let's watch our curves. See, yes, a little bit buggy. That's why you see some problems with the UI of my curves. Yeah, I think this will solve the problem of my gradient ramp. Okay. Let's delete those keys. And the keys from the frame number 0. Yes, keep it clean. And yes, we need something like this. Yeah, I think it should be much more easier to make it from scratch from the beginning and just not adding a new points. It's a little bit messy when you have a gradient ramp animated and then you're adding a new points and you animate them as well, and you will get this some troubles. But you see, basically it's very simple gradient ramp, animated white stripe. Okay, let's add some noise a little bit, not too much, to give some variations. Not just very straight line, but not too much, because we still need to follow our shockwave. Also inside our source we need to replace our smoke channel map for just a cellular map. So we will keep our gradient ramp inside the velocity, but this cellular map will be inside the smoke channel. So we will give some variations to the amount of the smoke from the ground. So some areas will emit more smoke, some areas will emit a little bit less, and it will bring a little bit more details in front of the camera. Let's try to simulate what we have now. Probably I made some mistake inside the cellular map. I wrap it inside the output map to invert my pattern of the cellular, also the wrong size. So you can watch the parameters on your screen for this map and try one more time with new settings. Basically this map is not very important, but I think it brings some nice details. Okay, this is what we got from our simulation, and it looks quite weird. I think, yeah, it's not good. Stop it. Let's increase our force of our wind and increase smoke buoyancy, and change the randomized settings as well, and try one more time. As you see, again, we are just playing with the parameters until we get the look of the simulation what we need, and it's still wrong. Let's change the start frame of the simulation and increase more influence of our wind, and maybe add some vorticity to kind of turbulence with this turbulence per object from Phoenix FD. Let's include it to our simulation and try one more time. And something wrong. Okay, still wrong. What's the problem? Oh, my bad. I inputted wrong start frame. Yes, let's start our simulation. Okay, this is the result. And yes, we obviously can see the vorticity effect from the turbulence object, but I still cannot feel the wind effect, and it is weird. It is already very strong, but still our smoke is not affected. Okay, I think we need to stop this simulation. Probably I will do a check of all parameters and my setup behind the recordings, and I will show you already the final result. Also, I will do some more detailed simulation. And here's the result of my some work behind the recordings. I did some tweaks of the parameters. I did this simulation. See, it's almost 100 millions of cells. It's quite high detailed simulation. And now I'll show you parameters. The cell size is 0.35, is quite low. Now you can see the bounding box of my simulation. It covers exactly what my camera see, just in its sector, you see, just here, because it is very heavy simulation, almost 100 millions. And this is the parameters. Time scale is 2. Everything is 0, 0, vorticity, randomize, fluidity, steps per frame. And the problem was that I didn't include my the planar force, this one. It wasn't included in my simulation. That's why it was some problems before. This is its strength. You can see on your screen. It is strong at the beginning. The turbulence is not included in this simulation. I decided to go just with the wind. And this is the parameters of my source. I still keep this gradient ramp. I didn't change it at all, actually. So also I didn't change the cellular map inside the smoke channel. So that's it. And now I will go through the rendering settings. The steps is 90. The fire is disabled. Everything rest is on your screen. The only thing here is animated is a graph inside the smoke opacity. I made the animation for this to keep the details of the smoke at the beginning. You see it on the left side of the image. very obvious and details are clean, and the smoke is almost zero transparency. And when the dust covers the camera, the right side of the image, I make it a little bit transparent to be able to see explosion and the rest of the scene through this smoke, dust. You can check the graph of the opacity from my tutorial and just copy it, or you can create your own, because probably your simulation will have a different opacity requirements. And this is the test render which I made with our near dust simulation. As you see in the beginning, the density of the dust is very high. We can see the details, and in the end it gets transparent, so we still can see our explosion. I think this is the great moment to end this part of the tutorial. Thank you for the watching. Thanks for the feedback for the previous parts of the tutorial, and see you soon. Bye bye.